This is breaking SSL using timing synchronization attacks. So please welcome Jose Selvi.
Hello, thank you to be here in this track. Well, my name is Jose Selvi. We're going to talk about some kind of attacks that we can use against SSL using time synchronization attacks. I have been working, just a brief presentation, I have been working for the last 10 years in the security industry. And at this moment, I'm a senior security consultant at the NCC Group. You have my Twitter and my blog there, just in case you want to follow me. But well, at the end of the presentation, I have the email and everything. So, well, I'm from Spain, from a city that is called Valencia in the Mediterranean Sea, which is a nice city where the paella is from. I don't know if you know, with beautiful. It's a nice city, so if you are at some point you are nearby and you want to have a drink in the beach, you just need to drop me an email and I'll be happy to share some drinks with you. So, what's the time? This is a key question in this talk. So, I remember when I was a kid or a teenager that computers were built like thinking that they were like standalone boxes. But now everything is very different. Vendors design the operating systems thinking that the computer is going to be connected to the internet, right? And for example, now we have automatic updates, and we have time synchronization using the internet, not the BIOS as I was used when I was a kid. So there's something we are going to talk about, some features. I don't think that they are bugs. So, but well, because they work they should work, but we can abuse these functionalities. So I consider them more like features, more like than bugs. So let's go. This is the agenda for today. And I think the best is to start from the beginning. That is well, what happened when I started to doing this research. So what happened was that I was doing like a demo. Sometimes we have a set of demos to show to our clients, and one of these demos was to use SSL strip that most of you know, of course. And we had a problem. Suddenly, it didn't work. And why it didn't work? Because there was something new at that moment that is called HTTP strict access security. And that's why I started doing this research about time synchronization attacks. So how it works? It's when you have the first HTTPS connection, the server sends a header that says strict type of security, max age, and a number of seconds. This means the server says, okay, in the following 3 million seconds, around 3 million seconds, you are going to connect always using HTTPS. If the user types just the hostname, you are going to connect using HTTPS. And even if the user clicks an HTTP link, you are going to connect using HTTPS. So this is what HSTS does. And the harder part is the part of the client, the part of the browser part, because the browser has to manage all this, has to keep these policies and the time and everything. At this moment, all the most well-known browsers support this. I think the only exception is the Internet Explorer, but most of them. Now it does. Okay, cool, perfect. 6 months ago. Are you sure? Okay. So for us, then if we are trying to get an HTTP connection, we have this problem. We can get an HTTP connection if HSTS is working. So we can reach our target. The victim is there behind the wall. So and this is very frustrating. But this is even worse because we have said that is in the first HTTPS connection. So you could think, okay, so we have an opportunity before this first HTTPS connection. So the people from Google and from Mozilla say, okay, let's do a preloaded list with some well-known hosts, and then those hosts are the HSTS is enforced by default. Okay, so with this host is even more difficult. So what I thought about this is, okay, so if the victim is protected in this time, then what I need is a time machine. It's easy. So I just need to go 3 million seconds into the future, and then the HSTS catch is going to expire. So then I can reach my target. I love this sound. Okay, but what happened with the preloaded lists? Because we have said that those hosts are enforced by default. The point is that if you read the documentation, for example, this is from Google, what I understood when I read this for the first time, it's like they are like a static list. It says that are out of the box, are configured out of the box. If you read what Mozilla says, is pretty much the same. They say that HSTS is enforced by default. And this is an email that, well, another vendor sent me that say pretty much the same, that this HSTS is enforced by default. But the real truth is that the preloaded list is preloaded. It's not static, it's preloaded. When there's a host in the preloaded list, when you clean the cache and when you install the browser for the first time, it's like it creates a dynamic entry with a max age that is, well, this max age is 10 weeks. Okay? So it's not really, even if the documentation says that it's enforced by default, it's not really enforced by default. It's 10 weeks. So, you know, this kind of confusions sometimes can be, well, a bit problematic, you know. The only browser that I have seen where the preloaded list is really static is Apple Safari. There is a file, a plist, where you have the host and something that says INF. I haven't found any documentation about this, but I have tested, and if you change the clock on your computer 10 years into the future, 20 years into the future, it doesn't matter. They are always protected. So in this, only for Safari, this list is static. For the other ones, they are not. It's preloaded, not static. So, okay, we know that if we have a time machine, we could do something with this, the HSTS. But is there any way, do you know any way to change the clock of a computer from the network, for example? NTP? Yes. The NTP is what most, I think all the operating systems that I have seen use to synchronize the time. Thank you. And well, some of them are slightly different, but 99% is NTP. The configuration can be different, but most of them are not secured by default. So you can do a man-in-the-middle attack against this protocol. This is an example of an NTP packet, or UDP packets. The format in the request and in the response is the same. There's only a flag that changes that says client or server. And there are some timestamps that are used to know what's the proper date and time. There are some maths behind this, but it's not interesting for us now. So what I did was to create a tool that is an NTP server, but with some modifications that led me to use some flags to do several attacks that we are going to see. This is the link. I have just uploaded the last version like half an hour ago. So this is the flags, but this I think is much easier if we see some examples. So for example, don't pay attention to the -n because it's just, it means not show the banner. But if you use the script without any other flag, what DeLorean does is to try to find a date into the future, at least 1,000 days into the future, with the same weekday and month day than today, because it's the date that the user can be, can warn the user. If suddenly it's Monday and your computer say that it's Wednesday, it can warn the user. But there are other flags that we can use. For example, we can say -n 10D, and 10D means 10 days into the future. But we can use -10D to go 10 days into the past, or -2 Y to 2 years into the past, or, well, we can do what we want with that. We can say a specific date, and there is another flag, -X, for random dates. So let's see the first demo. Okay, let me show you. This is a Mac OS X Just Might. And I have here some scripts. So we are going to set IP tables to say, okay, we are going to intercept all the HTTP connections and all the NTP connections. I have an HTTP server that is going to intercept all the HTTP connections. So if I try to type an URL and the HSTS works, I won't be able to intercept the HTTP connection. And if it doesn't work, I'm going to intercept the HTTP connection. So let's see what happened. We have Opera, Firefox, and Chrome, for example. And what is left? Well, there's something really important that we need now, that is for hacking, that is the proper music. Can you see the date? So it seems that it's working. Okay, enough music for now. So what happened was that if we change the clock in the computer, then the catch expire. So when the user connects, the computer thinks that we are 3 million seconds in the future. So the browsers connect using HTTP. So we can use the SSL strip and all the known techniques. There are other attacks that I have found to be like less useful. I coded them because I wanted to try them. But for example, a replay attack that you can say, well, you can have the pickup file with a response and say the DeLorean, okay, just replay this response. Or you can do like a spoofing or flooding attack that is the same, but without waiting a request, just flooding with responses. The problem that I have found is that NTP in Windows, Linux, Mac has a security control and anti-replaying control, and the transmit timestamp in the request has to be the same than the origin timestamp in the response. So if you replay something, it's not the same value. So they just ignore the response. Okay, but it's still in the tool because who knows? Maybe in another implementation can be useful. Okay. Okay, but in different operating systems, the synchronization works in a different way. So, for example, in Ubuntu, the synchronization happens each time that an interface, a network interface goes up. So, if you control the physical medium or the wireless network or whatever, you can just kick the computer out of the network, and when the computer joins again, you have a synchronization. So you can intercept this. And at least the last time that I have tested the last version, there isn't any additional protection to that. So you can change the date. In Fedora, you have an NTP request each minute. The only problem with that is that they do something slightly different. I mean, with NTP, you can the NTP client can just change the clock with a new date, or to make the time slower or faster because they don't want to make jumps. So this is what Fedora does. So this is a problem because if you want to change 10 years, the clock 10 years into the future, you can be some time waiting to that synchronization. But there's a point that the first three synchronizations, each time the Fedora boots up, they change the clock without any problem. I mean, directly. No speed up, no slow down. It just changed the clock. So if we are there when Fedora boots up, we can do the same that you have seen with Mac OS X. Mac OS X in Mavericks and Just Might has do something similar than Fedora, but the problem that we have here is that really there are like two parts. There are like an NTP daemon that is running all the time, and there is another service that is checking the information that the NTP daemon is storing in a file. But I have found, well, I and a lot of people have found that it doesn't seem to work. It doesn't seem to work. I don't mean my attack. I mean the NTP daemon. So there are, if you look at, well, search at Google about this, you can see people saying that it doesn't work. I don't know what happened, but my computer is not out doing the synchronization properly. And even there are people that have just, okay, let me to download my the NTP source code, NTPD, and now it works. But it doesn't mean that we can do the attack. I mean, we can do the attack, but we have the same limitation that in Fedora. This is the script that is run when one of the scripts that is run when the Mac OS X starts. And first of all, we have an SNTP, that is a simple NTP call, that this call works. I mean, if you intercept this, you can change the clock, right? And then we have the NTPD daemon, that this is where the bug is. Okay, well, I guess that is a bug because it is not working, the synchronization. There is another way to force a synchronization, that is just to open the date and time preferences. If a user opens this window, there is a synchronization, and you can change the clock as well. That is what I did in the demo. I opened the menu because it's easier than boot up the Mac again. Windows has the most robust time synchronization because it synchronizes once a week, and it doesn't allow changes for more than 15 hours. I mean, you can only change the clock 15 hours into the future or 15 hours into the past, which is not enough for most of the attacks that we could do. So it's a pretty robust implementation. Domain members work in a different way, using signature with keys, and it's pretty robust as well. This is the server. If you look at the task schedule, you have the W32 time service, that is the service that is doing this synchronization, and you can see that it happens once a week. Okay, this value, this 15 hours value, is not something that is hard coded. It's a value that is in the registry, and it's different in different versions, or for example, in Windows 7 and Windows 8, it's 15 hours. But for example, in Windows Server, it's 2 days. And it could be different in another versions. And when the computer joins a domain, it's different as well. So it changes depending on the configuration, the role of the server or the workstation. So attacking Windows using this technique is difficult in the default configuration, but I have found people talking in the internet about this, and there are people that think that once a week is not enough. So there are people, there are tutorials in the internet to change this frequency to twice a day, or each hour, or even each 5 minutes, or something like that. So what do you think that happen if I can change 15 hours the clock, but from one synchronization to the other, the time is less than 15 hours? What we can do is to jump just a few seconds before the next synchronization. Then wait that few seconds and jump again, and jump again, and jump again. Like this. 15 hours, 15 hours, 15 hours, 15 hours, right? I call this attack time skimming attack because it's similar to a stone skimming, that your stone is just jumping in the water, jumping and jumping and jumping and jumping. So we are doing the same, but with the time. So it makes sense, more or less. So this will be the command using DeLorean. This says that we want to jump 15 hours minus 10 seconds. Okay? And I have another demo for this, but I have a video because it takes around 2 hours to have. And we don't have 2 hours, right? People in the staff, we don't have 2 hours, right? No. So the video just are in fast forward at some point, and you have the DeLorean. And now if you have a look to the clock, the bottom right, you can see that the clock is changing 15 hours and 15 hours and 15 hours. From time to time, the Windows miss the response. I don't know why, and you have to wait to the following jump. So in around 2 hours, I think it was like a month and a half into the future, something like that. So in 4 or 5 hours, you can do the same attack that we have seen, but just with this configuration. This is not the default configuration, but it's something that you can find, because there are a lot of people saying, hey, change the time synchronization because it's much better if you synchronize each hour or something like that. There's another way that is less likely than in Mac OS X, that is the manual update. If in Windows you manually update the date, it works, and it doesn't matter that 15 hours limitation. It doesn't matter. It updates all whatever. Okay, but this is likely because you have to. It's not like in Mac OS that you just open a Windows and that's all. In Windows, you have to open like a couple of windows and click a button that says update now, so it's less likely. So as you have seen, this is not a silver bullet. It's an attack that is that you can use this attack, but you can't use this attack in all the computers, in all the configurations. But it's something that you can use and that I have used. So when I presented this, I presented the HSTS attack last year, and when I presented this, I had people working from Google sent me an email saying what happened with that, and we had some emails, and at some point a guy said that lots of things goes wrong when the clock is off, and he was perfectly right. In fact, at that moment, I was researching other possible attack surfaces. And this is what where I'm going to talk about now. I found one that I don't have a demo for this because it's difficult to find to do a demo with this. But I found that when even if it's not the most likely scenario, in a Windows, if you change the time, for example, 10 years into the future, and then the clock goes back to the present, there are some things that are weird in the task schedule. In some tasks, depending on the configuration of the task, the next execution is calculated in base of the last execution. So what do you think that happened if the last execution was 10 years into the future? That the following execution is 10 years and a bit more into the future. So it only happens with certain tasks, depending on the configuration of the task, but one of those tasks is the Windows automatic updates. So I mean, if the user tries to update manually, it works. But if you just trust that the computer is going to warn you, hey, I have updates for you, at least in the time that I had the computer testing this, I didn't have any update. And I had updates in other computers. So this is something that could happen when the clock is off. I have another attack that is against the public key infrastructure. I mean, we use SSL and we use certificates all the time, and those certificates are, well, the security of this is based on the trust on the CAs that are signing the certificates, and all the certificates has like a period of when the certificate is valid, right? But so if I can control the clock in a computer, what I can do is to use certificates from the past. I mean, certificates that used to be valid at some point in the past and are not valid now. So it's time to bring back to the life all well-known attacks. For example, we can try to exploit weak certificates. I didn't have any archive or database of SSL certificates, but I have found the SSL Observatory that has a database from 2010 with certificates. So then you can try to find, for example, certificates with smaller than 1024 bits that now are invalid, for example. And if you look at this, well, you have a number of certificates in this database. So I was trying to think, well, let's find something for the demo in DEF CON. And I said, oh, it would be nice to have something from Las Vegas. And I said, okay, search Las Vegas. But what I found was a few online casinos. But I have you ever seen the movie 21 Blackjack? Yes, I don't want to check if these things happen or not. So I thought, okay, let's find another. So let's find another example, like less dangerous, right? So I found something that doesn't seem very dangerous for me. This is a website from Disney. I'm really less afraid with this. So this is not the main domain, but it's one of the domains of Disney. So what I did was, it was a certificate with the key was 512, that we know that we can crack this, we can factor this now. And I used several EC2 boxes in Amazon, and it took like 3 days or 4 days or something like that. So if I have this certificate from the past and now I have the private key, and I can change the clock of the victim computer, maybe I could have an interesting attack here. So let me show. Okay. We are going to change now the IP tables rules. And now we are going to intercept, well, the same, the MTP, but the HTTPS instead of the HTTP. Okay. And we are going to say that we want to go 4 years into the past. That is the time that is needed for this certificate to be valid now. So let's see. DeLorean running. We are going to update now. And this is 2011, sorry. So let's see what happened when we visit the site. Okay. And the certificate chain is valid, and we have no warnings. Well, this demo, I mean, it could happen the same in a few years with 1024-bit keys. At this moment, browser updated doesn't accept 512-bit keys. So this browser is a bit old, okay? But it's an example for you to see that the same could happen in 3 years with more strong keys, okay? So okay, the same could happen with certificates that has been stolen in a security incident, for example. If we have the private key, the same could happen. Certificates that were leaked using the Heartbleed vulnerability. Maybe now it's too soon to use these certificates, but maybe in a few years that these certificates expire. And for example, one that that I particularly like is the Debian pseudorandom generator bug. I mean, this is something that happened in 2008. But we have some certificates that we can use. You can find these certificates in the SSL Observatory because the database is from 2010, and this bug is 2 years before. You can find some of them, but not really interesting ones. But if you look in the internet, I found this page that they do a plugin for Firefox, I think, and they had all the certificates that they found to be generated with the Debian bug. So at the end of the day, the only what we need for that is that the top root certificate has to be in the browser, the same the root certificate, and the other certificate chain, it doesn't matter if it's expired. So I just need to have all the public keys, the certificates in the certificate chain, and the public and the private key of the host certificate. And then you can do this attack. So, but what happened with the revocation list? I mean, you can use a certificate, but what if it's revoked? Okay. The point is that what I thought is okay, but the revocation list is a database, and it's not. I mean, it has a size, and if you are always storing more certificates and more certificates and more certificates and more certificates, it's bigger each time, and this is not convenient because the browser has to download this file, and so I was reading and trying things, and what I have found was that it seems that it's not mandatory that a certificate is in this list after it expires, because it's invalid because it has expired. So I can't be sure about this, but I have some suspect. Well, I think that probably there are some CAs that are removing all certificates, because I found, I did some, to compare the issue date of a CA with the first revoked certificate, okay? And I found that there are some of them that, for example, there is a difference of 4 years, 6 years. I mean, if you see, if there is a CA that was issued in a date, and the first revoked certificate is 6 years in the future, what I think is that they probably are removing the certificates, the revoked certificates that are not valid because of the date, the validity period now. But this is just what I think. I can tell you that this is 100% sure. Okay, and what if if the browser is checking the certificate, if it's revoked or not, using the OCSP service, it can be even easier, because what happened in the default configuration of, I think, all the browsers that I have tested, is that when they do a connection to test to check if the certificate is revoked or not, if they don't have response, they continue. So if you just drop the connection to this service, you don't have this check. So you can use revoked certificates. So I have another demo for this. Okay, let me change the virtual host that we are using, and the IP tables are the same because we are getting the HTTPS and the NTP. And at this time we are going to go 10 years into the past. So we are going to use a certificate that was generated using the old Debian pseudo-random generator bug, and we have the private key. So if we run DeLorean, and now I'm going to restart the daemon in the Fedora just because reboot the system will take more time, but it's the same. Okay. Okay, we have synchronization now. Let's see. Okay. The data has changed now, so now we can visit the site. The site, the certificate was the tools.ietf.org. So this site, okay? Okay. The certificate we have, the connection is valid. The site seems the original one, but I have changed the links, and now each link is a random security reaction GIF, animated GIF. Oh, this is a good one. It's a honeypot. And the certificate is, well, it's valid. And it's different. Let me show you. It's different from, if I can, completely different from the new one. Probably at some point they changed the provider. And it's completely different, but it's valid. Okay. So, well, you know, the time synchronization, well, it's something that probably should have more security controls, like Microsoft does, for example. There are a lot of other security controls. For example, Chrome has a warning if the certificate is, if the data in the system is older than the build time of the browser. So there are some controls that can that could help. I would like to special thanks to Pedro Candel, that is my third dealer, to Juan Garrido with some questions about Microsoft, to Tom Ritter, that is my factory mentor because it was the first time, and all the NCC group guys and resources, and the people who created the Back to the Future saga, War Games, and all those movies in the 80s. That was a wonderful childhood. And that's all. I think we don't have questions. Thank you. But I will be around here, and you have my email, so you can just drop me an email. Thank you very much. See you next time.